Okay, so in this section, we're going to be covering radical equations. And again, we're back in the real world now. And so again, if we get a square root of a negative number, we cannot do it. All right. So radical, all right, the the equation for that is going to be y is equal to square root of x, right? So it's the square root. And the graph of it looks like somebody kicking a field goal, a football into a field goal, all right, or someone throwing a ball. All right, so it looks like this. Okay, so that's a radical graph. That's what it looks like. Okay, now again, we're back in the real world. Can I plug in any number in for radical in the radical? Which numbers will not work? Negative, right? How about zero? Can zero work? Can I take the radical zero, square root of zero? Go ahead and type it in the calculator. See if you get an answer. Do we get something? Does it give us an error? It doesn't give us an error, right? So the square root of zero is just zero, right? So, but however, if we take in the calculator, go ahead and type in, say, the square root of negative four. What does that give us? If we type it in the calculator. An error. Yeah, right. So if I take any square root of a negative number, it's going to give us an error. Why is that? Well, again, you have to understand the graph. Mathematics is about understanding the graph. So if you look on the left side, right, this is zero. Okay. If you look on the left side of zero, there's nothing here. So it cannot compute anything. There's nothing here. There's nothing here. Nothing. There's nothing here. So it cannot compute, air. Okay, there's nothing there to compute. So, but I can pick any number in there, zero and above. Okay, all right. So let's look at a specific example. Right. So let's say we have, again, you can use any variables you want. So let's say we have 3x plus 4. So we have the square root of 3x plus 4, and it's equal to 2. All right. How do we solve this? Right? Well, we have a radical, so that means then we can get rid of the radical by taking the square on both sides. So we're going to take the square here and use a different color. Right? So I'm going to square on this side, and then I'm going to square on this side. So the radical and the square, they cancel, and then we're left with 3x plus 4 equals 4. Okay? And we continue solving. And so we subtract 4 on both sides. That cancels. We get 3x equals 4 minus 4 is 0. Then divide both sides by 3. So x gives us 0. 0 divided by any number except 0 will be 0. Okay? So the question is, what does this mean? What does x equals 0 mean? We went through the process, we went through the steps. What does that mean? Well, first of all, again, we have to understand what this equation is saying. But first of all, how many equations do we have here? How many equations do we have? Looking at this here. How many equations do we have? No, two, right? There are two equations. You're like, two, what are they? So just like we talked about the linear, right? We had like 3x plus 1 equals 2x minus 5. There were two equations. Y1 was this, y2 was that, right? Two equations. Well, it's the same thing with this one. We're going to have two equations. Okay, they're combining two equations. So what are they? Well, we have y is equal to the square root of 3x plus 4. And the other one is going to be, so that's y1, y2 is going to equal 2. Okay? So what does y equals 2 look like? What kind of graph does that look like? What does y equal 2 look like? Does anybody remember? Perfect. Exactly correct. It's a horizontal line, right? Y equals 2 is a horizontal line. Okay, so mark off 2, 1, 2. So it's going to a line going across. Okay, if I had x equals, say, 3, then that would be a vertical line, right? 1, 2, 3. It will be a vertical line going up and down. All right, so y equals 2. Another way to represent that, it's a horizontal line. Okay, so what's happening here? Well, what we're trying to do is the same thing as we were doing in linear. We're trying to figure out if these two graphs are going to cross at all, right? And if they do, where do they cross? Okay, so you have um, you have the let me, this is, right. You have the again, this is just a general example. This graph does not correspond to what we just did here. But again, you have the, radical, right? Y equals square root of x. And then you have, um, say 1, 2, right? The graph y is equal to 2, okay? And so what we're trying to do is we're trying to figure out, okay, what is the point of intersection? Point of intersection. Let me rewrite that. In intersection. Okay? What's the point of intersection? So in this case, the point of intersection for this particular example that we did was at x equals 0. All right? All right, so that's what we're trying to figure out. Okay? If we were to graph the radical and whatever is on the right side, there might be two radicals. That's okay. Where are they going to cross? If they cross at all. Okay? So that's basically the behind the scenes in solving these real equations. I'm sorry, these radical equations. Okay? Any questions on there? All right, so let's do some more examples. Okay, so again, we want to solve for x. All right, so in order to do this first, we need to get the radical by itself. Okay, so let's write down our goal. Okay, so you want to get the radical by itself. Okay, that's the best way to do it. Some people try to square both sides at the beginning. Don't do that. Okay, if you can try to get the radical by itself first, that's probably the easiest way to do it. All right, so in order to do that, notice that we have a -1, so we can add 1 to both sides. Okay, so then the -1 and the +1 cancel, and we have the cubic root of 1 minus 2x equals 1. Okay, so you have a cubic root, so that means then we can cube both sides. Okay, so the cubic and the cube are going to cancel, giving us 1 minus 2x equals 1. Okay, and then we're going to just keep going and solving. So we're going to subtract 1 on both sides. We get negative 2x equals 0, and then divide both sides by negative 2. So x gives us 0, right? So again, we can always double check our work by plugging in uh, whatever answer we get back to the original equation. Okay? Any questions on this one? All right, so let's do these next two. And one of them is actually going to be wrong. Okay? Or let's just look at them. Okay? So this one, we have the fifth root of 2x minus 3. Wow, look at that kind of big. Try that again. 2x minus 3 equals -1. And the other one's going to be the square root of 2x plus 1 equals -1. Okay, so again, go ahead and solve this, see what you get. Okay, so again, what we're going to do is right now both of them are have been isolated. One of is isolated. The radical is isolated, so we can just, you know, try to get rid of the radical. If not, then we would need to add or subtract or do whatever we can to get the radical by itself. Okay, so let's look at the first one here, right? We're going to raise this to the fifth power. Raise this to the fifth power. So the fifth root and the power go away, giving us 2x minus 3. And -1 to the fifth, that's just going to give us -1, right? Because -1 times -1, 5 times, right? It'll just give us -1. Then we're going to add 3 to both sides. So that goes away and gives us -1 plus 3, which is going to be 2. Okay. And then we're going to divide by 2. So x gives us 1 here. Okay, which a lot of you guys got. All right, now let's look on the right side here. So I'm going to do the same thing. The radical is by itself, which is great, so I can move on. So I'm going to square both sides. So then the radical and the square go away, giving us 2x plus 1 equals -1 squared is going to give us a +1. Then we're going to subtract 1 on both sides. That's going to cancel, giving us 1 minus 1 is 0. Then divide by 2. And then 0 divided by 2 is going to give us 0. Okay? So if we both, if we enter these answers in the lab, one of them is going to be marked wrong. Which one would that be? The first one or the second one? What do you think? You can make an educated guess. Okay? When someone says first one. So again, if I enter these answers in the lab, one of them is going to be marked wrong. Okay, we got another vote for the first one. Second one. Okay. Cool. All right. So which one is it? How do we know? Well, um, let's let's compare two things real quick. So let's say we have um, the square root, let's say the cubic root of -1 versus the square root of -1. Okay. All right. So notice that if I have a fifth root and I raise it to the power of 5, they're going to cancel, correct? So that's what I want to do. I want to rewrite the inside that radical by whatever the root is. So in this case, it's a root of 3. So I want to rewrite the inside matching that 3. So what do I mean? So that means I need to multiply inside this radical -1 3 times. And if I do that, is it going to produce -1? So if I have -1 times -1 times -1, is that going to equal -1? And the answer is yes, right? -1 times -1 times -1, right? That's times equals -1. And we can rewrite this as -1 raised to the third power. Everybody agree with that? Okay. So in this case, then, the cubic root of -1 we can write as -1 raised to the third power. Okay, Because again, we all agree that -1 to the third is equal to -1, right? So inside, they're matching. So I can rewrite it in this way, and they're still equal to each other. Well, now what happens? Well, the cubic and the power of 3 are going to cancel, leaving us with -1. And that would be our answer, okay? Now let's look on the square root of -1. What is that going to do? So I'm going to look at square root of -1. So, okay. So again, I'm trying to match the radical here, 2. So that means my power inside has to be 2. So I need to multiply the inside number twice. Okay, I need to, and then raise it to the power of 2. Okay, so there'll be -1 times -1. Well, what's -1 times -1? What does that give us? It's a +1, correct? -1 times -1 is a +1, but what? We want what? A -1, right? -1 does not equal +1. There is no way I can rewrite -1, right? Raise it to an even power and produce a -1. Okay? So in this case, on this side, there would be no solution. Okay? Because again, I cannot rewrite that negative number and produce a positive when it's an even root. Okay? So back over here, okay? So this one is an odd root, okay? And it will what? It can produce a negative output, which we just showed here, okay? So this one does work. However, in this case, we have an even root, right? So it can never produce a negative, all right? So even, right? We can't say the square root of 9, okay, does not mean -3, okay? You can't do that, right? The square root of 9 is just equal to 3, not -3, okay? So it can never produce a negative number. Again, we're talking about the real world. If we went complex, then that's a whole different ballgame. All right, so in this case, the first one, we do get an answer, but the second one is no solution. You with me? Okay. All right, so we have the fourth root here. Okay, so we're going to raise this both sides by to the power of 4. Okay, and then so the fourth root and the power go away, and we have x squared plus 16. And radical 5 to the fourth, remember, the radical 5, I can write that four times, right? There's another way, and I'll show that in a second. But radical 5 times radical 5 is radical 25, and radical 5 times radical 5 is radical 25. And radical 25 is 5, and radical 25 is 5. So 5 times 5 is going to give us 25, okay? Again, I'll show you a different way in a minute. And then we have x squared plus 16, so we're going to subtract 16 on both sides. That cancels. So we have 25 minus 16, which is going to give us 9. Then we take the square root on both sides. So x is going to give us plus or minus 3. Okay? And we can plug those in there and we will get both of them to be correct. So that will be our solution there. Any questions on that one? I'm going to show another way to write the right side of this equation. But before I do that, I'm asking the question, if we have the square root of x, and if we square it, why does it give us x? Why does that work? All right, so again, the question is, if we have the square root of x and we square it, the answer is just x. And the question is, why does that work? All right, and it has to do with the radical, okay? The square root of x. What's another way to write the square root of x? What's another way to write the square root of x? right? The square root of x, right? There is a root of 2 right there, right? This is a root 2. We don't write it, but there's a root 2 here. Okay, so I can rewrite this as x to the 1/2 power. All right. If I have the cubic root of x, I can rewrite that as x to the 1/3 power. If I have the fourth root of x, it's x to the 1/4 power, so on and so forth. So the reason why it works is because if I were to rewrite square root of x as x to the 1/2 power, then I raise it to a power of 2, right? A power to a power, we multiply. So 1/2 times 2 is just going to give us 1 because the 2's are going to cancel. Okay? So that's the same thing here. The 2's are going to cancel, leaving us with x to the 1 or just x. That's why it works, because the root, okay, will cancel with that power. All right, so you give me any root, cubic root of x, I raise that to a power of 3, that's x to the 1/3 raised to the third, that cancels the root and the power, leaving us with x to the 1. Okay, that's the reason why it works. All right, so in this case, I'm going to rewrite this as a root, okay? Or rewrite the root. So I have 5, right? Raised. So the square root of 5 is 5 raised to the 1/2 power. I can rewrite, I can rewrite square root of 5 times. I mean, sorry, 4 times. But I don't have to do that because I know the square root of 5 is 5 to the 1/2. So if I raise that to the 4th power, right? That's just going to be what? Half times 4, or half of 4 is just going to give me 2. So this is going to be 5 squared, which is just 25. That's the easiest way to do it. Okay. Changing that root to 1/2, 1/3, or whatever that root is, and raising that and dividing it. Okay. All right. Any questions there? All right, so let's look at the first one. We have x is equal to 3 square root of x, right? So we can divide the 3 and we can get x over 3, getting the square root of x by itself. And then now we'll have fractions, and I don't want to deal with fractions. So sometimes leaving it the way it is okay. All right. So what we could do on the first one is we can just straight square, right? So I can square this side and I can square this side. Okay. So when we do that, what happens? Well, we're going to have x squared, and then this is written twice. So it's 3 square root of x times 3 square root of x. Okay, so I can multiply these guys. That's 3 times 3, and then I have square root of x times square root of x. And then multiply those guys. Okay, so that's going to give us 3 times 3, which is 9, and the square root of x times square root of x is just going to be x, right? Or it'll be the square root of x squared, right? Which again will just be x. So 9 times x. And this here will bring it down to x squared. Okay? Now you have to be careful. If I divide by x, okay? If I divide this by x and divide this by x, right? I'll get x equals 9, which is true. However, if I do that, I'm getting rid of one of my solutions. So I don't want to do that. Okay? Right? I don't want to do that because the 2 tells us we have 2 possible solutions. So I don't want to divide by x. So what I can do is I can just move the 9x to the left side, giving me x squared minus 9x equals 0. Okay? Now I can factor, because I have an x and x here, I can factor an x, leaving us with x times x minus 9 equals 0. Okay, so that's going to give us x equals 0, and x minus 9 equals 0, or in this case, x equals 9. So we'll have two solutions here. Again, you want to plug it back in because sometimes you might have, okay, I got these solutions, and you enter it in the lab and it says, sorry, that's not correct. It says one of them might not work. Okay, so you always want to double check and make sure that they do work. Okay, so in this case, they do both work, right? Okay, any question on the first example here? Okay, the next one I really want to emphasize because, again, it's a common mistake that students make. So this one we have 2 plus the square root of 12 minus 2x equals x. And what a lot of students will do is do this, okay? And let me pause this. Okay, so a lot of students will do this. They will square both sides, okay? And they'll say, oh, I got 2 square, and then I have plus, and then this guy's gone, so I have 12 minus 2x equals x squared. Okay, I see that a lot. And that is not correct. Okay, that's not true. This 2 plus square root of 12 minus 2x means I need to write that twice. All right, I need to write it twice. All right, that's what that means if I square both sides. Okay, I can't just cancel it. And the reason why is because there's a plus in the middle. Okay, in order for me to cancel it is if I have a, say, a square, all right, say square root of x and then 3, then I can square it because it's this being multiplied. It'll be 3 squared times the square root of x squared. I can do this. This is okay. But in this case, there's a plus in there and I just can't distribute that square to each of the terms. Okay, that doesn't work. Again, this here means I have to do it twice, and that's a lot of work. So what we can do is, right, like I said before, we can try to get the radical by itself. So what we can do is we can subtract 2. We can subtract 2 on both sides, and we get square root of 12 minus 2x equals x minus 2. Okay, and then now I can take the square on both sides, and then the radical and the 2 will cancel, giving us 12 minus 2x. And again, this here does not mean x squared minus 2 squared. No, that's not true. Okay? Because there is a minus there. If they're being multiplied, yes, you can do that. But there's a minus there. So that means I have to do this twice. X minus 2 times x minus 2. Okay? Then you just do the full method. Or one little trick I do is, I know if I'm multiplying the same factor twice, what I can do is I can just square the front, square the back. 2 squared is 4, x squared is x squared, then multiply the 2. So that's negative 2x and double it. So that will be negative 4x plus 4. Okay? All right, again, if that you don't feel comfortable doing that, FOIL it out. Okay? And then the left side is 12 minus 2x. Okay? So then I'm going to move everything to the right side because I want a positive leading term. Okay, so I'm going to subtract 12 and add 2x. Subtract 12 and add 2x. So these guys are going to cancel. And we're left with 0 there. And then here we'll have x squared minus 2x minus 8. Okay, and then we factor this, we get x minus 4 times x plus 2. So we'll get x minus 4 equals 0. And then x minus 2 equals 0. So in this case, we get x equals 4, and then x is equal to 2. Okay, and it looks like Sorry, that's -2. No, I messed that up. So we got it again. So that's x minus 4 equals 0, and then x plus 2 equals 0. So that'd be x equals 4 and x equals -2. And so anyway, so x equals 4 works, but if I plug in -2 in here, right, it's not, the -2 won't work because it's telling us that this here is equal to -2. And that's not true, right? Remember, the square root cannot produce a negative. It's always positive. Okay, so in this case, that one doesn't work. All right. So first of all, again, I'm going to put a disclaimer here. If you did this, oops, all right, it is not correct. Okay. So if you had square both sides and then cancel these guys here, that's not correct. Okay. Can't do that. All right. So please don't do that. So the only way you can cancel them is if this was being multiplied. All right. They're not, if there's addition or subtraction, you can't do it that way. Okay. All right. So what do? Well, remember I said one of the best ways to solve this is to get the radical by itself. And right now we have two of them. So that means we can get, we can do one of them. All right. Doesn't matter which one. I'm going to pick the square root of x plus 2 and move that to the right. Okay. So we're going to have the square root of 3x plus 7 equals 1 minus the square root of x plus 2. Okay. All right. Now what I can do is, now I have one of the radicals by itself. Sorry, I'm going to write a little bit small here and need as much space as I can. I'm going to square both sides now. Okay. So when I do that, the radical and the square cancel. We get 3x plus 7. And remember what I said, that this is the same thing as multiplying it twice. Okay. So you would multiply this twice. All right. So, okay. To save us some time, all right, so again, you would multiply this out. When you do that, you should get 1 minus 2 square root of x plus 2 plus x plus 2. Okay? So again, when you multiply this out, the right side becomes 1 minus 2 square root of x plus 2 plus x plus 2. Okay? All right, now what I'm going to do is I'm going to combine my like terms. So I have here 1 and the 2 there, right? So I can write this as 1 minus 2 square root of x plus 2 plus x plus 2. So I got a 1 and a 2, so this becomes -2 square root of x plus 2 plus x plus 3, right? I'm combining these guys. So 1 plus 2 will give me 3. Okay. All right. Then I'm down here on the left side, I still got the 3x plus 7. All right. And now I'm going to subtract x and 3 on both sides. Okay. So the x's cancel and the 3's cancel here. And then we have 2x plus 4 equals -2 times x plus 2. Okay. Now, what we can do here is I can divide everything by, notice I have a 2 here, right? And these can be factored. I can factor out a 2. So what I can do is I can divide both sides by 2. I'm actually going to leave the negative there, all right? And there's a reason why. So I'm going to divide both sides by 2, okay? So that 2 cancels, and I still have a negative and the square root of x plus 2. And then this is going to reduce, right? Because it's going to be 2x plus 4, and it'll be 2 times x plus 2, okay? And then if divided by 2, then the 2's are going to cancel. So this here is going to leave us with x plus 2, okay? Then I'm going to take the square, I'm sorry, and then I'm going to square both sides. And so the left side here, again, this is saying x plus 2 times x plus 2, okay? And when I multiply that out using the FOIL method or whatever method you like, we get x squared plus 4x plus 4. And then this, in this case now, since this is a -1 times this, then I can distribute it. Then I can square the -1 and then square the x plus 2. Okay, the square root of x plus 2. So this becomes a +1. And then the radical and the square cancel, giving us what x plus 2. Okay, like I said, I need a lot of space. So now I have, let's simplify this a little bit. We got x squared plus 4x plus 4. And then 1 times x plus 2 is just going to give me x plus 2. Okay, then I'm going to subtract x on both sides and subtract 2 on both sides. So then these guys are going to cancel, giving us 0 on the right side. And on the left, we're going to get x squared plus 3x plus 2. Okay, now I can factor. My factors are going to be x plus 2 and x plus 1 equals 0. Then set them both equal to 0. All right, and that gives us x equals -2 and x equals -1. And it looks like -1 is not going to work, so our only answer will be -2. Okay, what I like to do is I actually want to finish off and multiplying the 1 minus square root of x plus 2 and the 1 minus square root of x plus 2 to show you how I got the 1 minus 2 square root of x plus 2 plus x plus 2. Okay, because I know that can be pretty tricky. So I'll have it here as my scratch work. So again, I'm just going to use the distributive property where I'm going to multiply the 1 to that term and then do the same thing for the minus square root of x plus 2 and multiply to that, let's just say expression or factor. All right, then I'm going to distribute this. So I'm going to get 1 minus the square root of x plus 2. And then I'm going to distribute that. That gives us a minus square root of x plus 2. And here we're going to have a negative, and negative gives me a positive. So that'll be the, we have 2 of those. So the square root of x plus 2 squared. So the radical and the square will cancel, giving us x plus 2. Okay. All right. And then here we have 2 of the same radical. So that becomes -2 square root of x plus 2. And we still got the 1 in the front. Okay. Now we can simplify. We have, well, let's see. Yeah. So I just simplified here, but that's what I got. So I got the 1 minus 2 square root of x plus 2 plus x plus 2. That's what I got here. Okay. So I just wanted to show you how I got that answer, just in case that was throwing you off.